So in this video, we are going to talk about how the system works, how we are going to implement it inside the steel pipeline, and I will tell you how we make the pipeline maintenance system easier as well as less expensive while saving time. Requirement of removal of pipelines from their existing place and then bringing it down and then manually cleaning it and then replacing it there, it is very expensive as well as time consuming. So this machine avoids all those problems and all the while being remotely controlled, fully wireless DC system. Let's talk about the power electronics and the control electronics of the M-TBM. This whole system is electrically isolated, insulated, and waterproof. Isolation works is that we have internal batteries, so we don't need external wire connections. We don't need a power generator that needs to power this machine. We can just charge the batteries, bring it on the work site, and insert those batteries, and we are ready to use it. Secondly, it works on two types of DC voltages. It has a 24-volt DC architecture for the wheels and for the actuators, while it has a 72-volt DC architecture for the main shaft control. The whole system is waterproof, as I said, means we don't need to worry about any electrical fires or any grounding shorts. Also, the wheels, they are made up of insulated material, so no grounding effect can travel directly inside the pipeline and charge the surface of the pipeline. So as you can see, we have a inbuilt water system. This water system accepts a industry standard fire hydrant line of 63.5 mm, and this pressure is controlled from the pressure in the fire hydrant is controlled from the mains of the fire hydrant line that is situated inside the water pumping of the company. Water then travels further towards this place, and this is the first point where it leaves the manifold. This is all rated for 10 bar pressure, and this is the 1-inch opening. It provides a exhaust flow, the restricted exhaust flow, which creates a pressure into the second exhaust. That is a half-inch pipeline exhaust. It has more pressure, so it is a pressure flusher and it is a volume flusher. It has a large volume of water which has low pressure. It can create a big puddle of water over here, while this one can drain all the all the wash debris from the front of the machine, and it can drain it backwards. While this one floods the area, it will keep the debris that comes from the forward inside that flood, inside that puddle. Also, the remaining water then travels into this manifold. It is then transferred into six outages, and they travel into this flange, which carry fountain hoses, and they spray the water. I will tell you how we can optimize this machine to suit different diameters. First thing that we will need is a new casing, a casing that will suit the size of the pipe that we need to service. It needs to be 100 mm smaller than the size of the pipe. Also, then we will need to change these leg attachments. We'll need to make them shorter or longer. It is a finely adjustable one, but it does not provide more adjustment than 20 millimeters right now. So we'll need a different set of these rods. These are all aluminum rods, and they are lightweight as well as very rigid. So after we change all the geometry of the machine, then we'll need to change the shaft cutting geometry. We'll need to install different sizes of these cutting wire ropes, even different kinds depending upon the condition of the pipeline or the nature of the debris. Let us talk about the cutting mechanism. The cutting mechanism is formed by wire ropes that are mounted on this shaft. There are a total of 12 of these wire ropes while rotating at a speed of 5000 rpm at max. These wire ropes form a gradient. This cutting action is supported by a water jetting system. These six outlets supply water from the inlet manifold coming from the back of the machine. They spray water directly onto the shaft and it takes it and splashes it all over the internal circumference of the pipe. Due to which we have very low dust inside the pipe. No sparks are formed because these are all lubricated while the inside of the pipe also get lubricated because of water spraying. Thirdly, we have already tested the efficiency, the performance of this cutting design and mechanism inside Tata Steel Kalinganagar in the first version of this. The M-TBM is supported on three wheels. The central wheel, it is the load bearing wheel. It carries all the weight of this machine. The weight of this machine is 200 kgs approx. The machine itself weighs 200 kgs and 70 kg is the weight of this casing. This is the main load bearing wheel. It will carry all the weight. While these two wheels, they are traction wheels. So they are chain driven. Both have dual chain drive. They are powered by gear motor and each set of wheel delivers a torque of 60 Newton meters on each side. Means the total combined torque of the M-TBM is 120 Newton meters, which can help it push even through semi-clogged pipelines and without worries. Third thing is the linear actuator. These linear actuators, what they do is they can clamp this whole mechanism onto a certain place and also release the load so that we can slide the whole machine backwards in case of recovery or in case we see a certain obstacle is there which needs to be dislodged in a different manner. I showed you just how easy it is to pull this machine because the whole system gets free once the linear actuators are retracted. So we are going to actuate the linear actuators. I will show you much better. You can see the legs are changing their position. Each linear actuator applies a load of 600 kgs on the walls of the pipe, effectively clamping the whole system at its given position at any given time. So, as you can see, we just brought the M-TBM towards us. Now I am going to demonstrate the shaft, how it looks while it moves. This is the speed of almost 1500 RPM, and I'll show you the top speed for a few seconds. That was the top speed. So I'm going to explain you the water system of this M-TBM. What we have made is, this is a nozzle. It is a fire hydrant nozzle. It can accept 63.5 mm standard industrial diameter fire hydrant, and also it can withstand the force of 10 bar. The whole manifold is rated for that. We have maximum withstanding capacity of 10 bar of pressure. So we will accept the fire hydrant hose over here. Then the manifold is designed such that it distributes the pressure into 8 channels. First channel has a 1-inch diameter opening. It helps in high volume drainage. The second exhaust is over there. It helps in high pressure drainage. The remaining water is sent outside from the nozzles at the cutting shaft, near the cutting shaft. So the pressure can be controlled by the operator who is setting and controlling the main line of the fire hydrant pressure. And we can visually monitor what is happening inside the pipe, and accordingly we can then adjust it. Now since we have extended it fully, I'll show you how it moves. We'll have to pull it back a little bit because it has gone beyond. Okay, so now we are in the position where the M-TBM is in the place where the shaft itself is outside, as you can see. Now we can test the shaft itself. As you can see, the rotation is silent. So once again, I'm Adarsh Gautam from Grass Engineering. I hope you liked the demonstration. And if any requirements or any questions, you can reach out us officially on our website and our email. Thank you.